Hello, and welcome to our inaugural podcast of manufacturing use cases. I'm Sree Hameed with AVEVA.
I'm Tim Stuart with Visual Decisions.
Tim and I have been collaborating with each other for well over 20 years, where we both share a passion for all things related to the convergence of lean manufacturing and digital transformation. To introduce our new podcast series around the topic of manufacturing use cases, we thought it would be helpful to go through 4 basic questions.
Digital transformation projects see a higher risk of failure than success. One way to mitigate this risk is to take a use case focused approach. In our experience, when done right, a good use case serves as an effective bridge between the value discovery stage and the value delivery stage. At the start of the transformation journey, the use case is the thread that ties together the identification of pain or opportunity, the business case for investment, and the search for solutions as part of discovery. And you build upon that use case to plan the implementation, do the rollout, and perform the value audit to show that you have delivered on the business case as promised. It looks straightforward, but in reality, we find that both end users and technology providers struggle to put together good use cases. And that's why we're kicking off this podcast series to see if we could help. The initial set of episodes will focus on the value discovery side of the equation. In future episodes, we'll address the delivery side of the equation.
Great. So let's move to the second question. What's a repeatable format for discussing each episode? So the format, I should say the framework we put together has 4 basic elements to the use case. And we'll use these 4 elements as the standard structure for each episode. The first element is the KPI or the metric. So when we identify a pain or an opportunity for improvement, we also have to identify what metric that we want to improve and who's accountable for that. The second element is the business impact. In other words, how do we build the business case? The third element is the root cause or causes of the pain and how to diagnose that. And then the fourth element is the enablers. How do people, process, and technology come together to enable the solution? If we focus on these 4 fundamental elements during discovery, then we'll see that it also involves the right stakeholders and helps ensure that they're all on the same page throughout the transformation journey.
So, third question, how do we go about choosing the KPI for an episode? A use case can be tied to one or more metrics and KPIs. What we have here is our menu of KPIs. So let's explain our thinking and how we put this menu together. We started with SQDC, safety, quality, delivery, cost, which are the 4 basic but well-known categories. Next, we wanted to make sure we covered all the critical functions. So we added reliability to cover maintenance, environment to cover facilities and sustainability, and workforce because safety alone isn't enough. Next, we wanted to point out that sometimes it's necessary to discuss a KPI at both the corporate level and the plant level. And finally, some of our most important KPIs are a composite across multiple functions. So that's the menu. It's not an exhaustive list, just enough to give you an idea of our approach and thinking.
And then the fourth and last question, how much time do we spend on an episode? This is something we went back and forth on, and we decided to keep each episode to 15 minutes. And our thinking as to why, in a real life project setting, use case could easily, well, first of all, it's going to take multiple KPIs. It'll cover multiple KPIs, and the discussion can easily take up to a full day in a workshop setting. And the context is going to be very specific to your particular industry and your production environment. Rather, what we have in mind is more of a rapid fire checklist, general enough to cover several industries, and good enough to jumpstart the brainstorming process and get you thinking the right way. Because of the time constraints, we can show the financial impact, but we don't plan to get into the calculations behind the financial model. We can do a separate episode on that entirely. So where we plan to spend most of the time is in the root cause diagnosis and the solution enablers, bringing that together in designing the solution. So that's the plan, keeping it short and sweet. Try this approach and then adjust as needed based on your feedback. So obviously for the first episode, we won't be able to meet our 15-minute goal since we need the additional time to introduce and set up the context for the framework that we're about to walk through. But with that said, let's move on to our first KPI of our first episode, which is first pass yield. Tim, get us started with a definition of what it is and who is responsible for it.
Sure. So first pass yield is one of your most basic quality metrics. Looking at an individual process, first pass yield is the rate at which good parts are made in that process without performing any rework. And it's most commonly used within discrete manufacturing processes. Calculation is simply the number of good units divided by the number of total units, or the number of total units minus bad units divided by total units. If we look at who's responsible for it, in most companies, the production team is ultimately responsible for that, but they're going to get a lot of help from the quality team and the continuous improvement teams.
And Tim, this is a very broad metric, and I should say it's easily in the top 5 metrics for manufacturing.
Yeah, if I look at discrete manufacturing, this is absolutely one of the bedrock, most common metrics across all of those companies.
And in batch industries like food and beverage as well, right?
Yeah, particularly on the packaging side, but also on the batch side. It's not universal there, but it's very common there as well.
Great. All right, so let's move on to impact. So we've captured the impact on this slide, and it's largely self-explanatory. But in the interest of time, I suggest we focus only on the significant impact first, because that's the foundation of the business case, and then moderate. We won't be spending time on the minimal impact, but acknowledge that it will be accounted for in an actual value estimation exercise.
Right. So if we look at the left side here, and we think about protecting the brand promise, quality product in the marketplace is obviously a huge part of that brand promise. And so if you have first pass yield issues, you're producing bad parts, some of those will get through an inspection process and end up in the customer's hands. And that's going to hurt that brand promise. For things that don't make it through, that get caught by inspection, you're still going to have waste within the process. You're going to either have rework or scrap to eliminate that bad part. And so those things are very, very heavily impacted. Likewise, on the income statement side, material costs and direct labor are going to be directly impacted because of the fact that you have invested in those materials and in that labor to get that part to that point before it gets rejected.
Great. Let's then move on to the root cause analysis. Mm-hmm. So here we are using a fairly well-known framework known as the Ishikawa diagram or fishbone diagram to capture cause and effect, and specifically designed to identify root causes of variability. What we have done is simply lay it out a little bit different. So for each KPI, in this case, for first pass yield, we've organized the remaining categories of the Ishikawa diagram of machine, material, environment as the physical dimension, and the remaining dimensions under process, people, and policy. Now, keep in mind that this is meant to be a helpful checklist to help identify what's specific to your environment, right?
Yep. Yeah, within any particular manufacturer, there could be a lot of different sources of variability. And what we've done here is just thrown out some common things within each category. So if we look at the machining side, I'm starting with the physical. If the machine is poorly maintained, if it has tooling issues, or if it's not capable of that required tolerance, you're going to end up with excessive variability in the process, which will lead to those quality issues. I should step back and say that the reason that we have source of variability at the top is if we're looking at quality issues and first pass yield, variability is the source of that. For every quality problem, it's really a variability problem. You just have a curve of outcomes and those tails. If those tails are beyond the specs, then you have a quality issue. So getting back to the chart, if we look at materials, it could be the input materials, it could be a mix of materials, there could be defects in the material itself. And so those could be sources of variability. Within the environments, I'd like to give an example of a company that I worked with that loads spices into containers. And if the humidity is too high, the spices clump and they get overpacked. And so other customers I've worked with, temperature, humidity, vibration, particulates in the air, all are big sources of quality issues. On the right side of the chart, if we look at the process, if you have a lack of standard operating procedures or standard work, that's going to drive excess variability in the human, how they actually do those things, or it could be machine setup and so forth. Or if you have poorly defined SOP, or if they're just not visible and so forth. From a people perspective, if you have a lack of or ineffective training, if you have high turnover, if you have a lack of enforcement, if people are off work and you have to have somebody else sub into that process for that day, you could also have those issues. And then from a policy perspective, from a management look at things, you could have, they're responsible for setting the culture and the mindset of creating a quality part every time in the first place. So there's some aspect of management typically in all of this. If you have a poorly maintained machine, that is directly a machine issue, but it's also kind of a management issue that they haven't invested in that process. And then there's just a lack of awareness possibility from management as well, that they just don't understand how to drive that quality process throughout the entire organization.
Yeah, and again, we need to reiterate that this is not meant to be an exhaustive list. It's just a starting list, but that helps you to do the root cause diagnosis in a disciplined way. Another thing to point out is that, fishbone diagrams are not new. They've been used for root cause analysis for a while, but you can also think of it as a way to understand the hurdles or the inhibitors to smart manufacturing, right? And I think it serves as a good check against the tendency to put the technology cart before the process horse, right? That you do this first, and then you go look at the requisite technology that you can fix. So that also brings us to the topic of enablers. Industry 4.0 has introduced a new language with words like digital twin, smart manufacturing. So in our use case framework, we are introducing the concept of a digital nervous system. Now, we can't take credit for this label because it was first coined by Bill Gates way back, well over 20 years ago. But it is a more descriptive concept because it captures the idea of a living digital twin that can see, know, and act via a closed loop process. So this living digital twin forces you to think about the closed loop process. Again, we talked about sensing and responding. Well, then the next question is, what is the cadence of that closed loop? How quickly do we need to close that loop, right? Because at the process control level, is that within seconds or milliseconds? Is it at the supervisory control level, at the MES system level, where you're doing all the orchestration of the activities within a shift? Or is it at the ERP or supply chain level, where the process cadence is usually measured in days and weeks? Right. So in my opinion, the the DNS, or I should say the digital nervous system concept, is more useful as we head towards this new world of AI and agentic workflows and all this other stuff, right? So with this backdrop, let's actually move to how we think about solution design, right? So here we've brought the enablers and the root cause analysis together, and we'll start again with the physical aspects, starting with real-time sensing, and we'll work upwards through every one of these control loops.
Yep. So if you think about quality issues and the variability that's happening within the process, one way that you can start to address this is to, in real time or near real time, identify when you have excess variability happening. Now, in manual processes, what we've put in here as an example is to do video monitoring. There are solutions available that help you monitor the movements of people within the process and so forth. And you can automatically detect any deviations from the standard work as they're going through that process. From a machining perspective, it's much more condition monitoring. So you're monitoring through sensors, or you're monitoring through the PLC or controller of the process, and looking at the actual process variables to identify where you have deviations or where you can start to predict deviations are occurring. And that's happening at that very detailed level. Now, at the next step up from that, we start to get into the predictive analytics, because, as I said, with the condition monitoring, you're capturing that data at that detailed level. But typically, a single data point, unless it's a very extreme data point, isn't going to predict a coming failure. It will say that you had a failure. You need a series of data points typically in order to predict that you are trending towards a failure. So that's where the predictive analytics takes a little bit longer to make that prediction. And then you have in-process testing that's happening right at the process that will tell you from an SBC perspective, perhaps, that you're trending towards a failure. And then you have process isolation. Process isolation is going to help you identify when the humidity is trending, when the temperature is trending, et cetera, and be able to either make adaptations in the HVAC process or somehow isolate the manufacturing process from that environmental change so that it doesn't impact what's happening within production. At the next level up, we start to aggregate information across multiple instances of the build and so forth, and we can start to look at the analytics. And we can look at the analytics for the day, for the shift, and start to identify trends within there that are going to tell me what are the course corrections that I need to make in order to maintain higher quality and so forth. From a material perspective, that's going to look at the inbound inspection and identify that I'm actually getting quality material coming in from the source. At the next level up, we can look at things that are more programmatic. And if we look at things like maintenance programs, moving from reactive maintenance towards preventive and then predictive and then even prescriptive maintenance. Those are things that are going to have a long-term impact on my ability to avoid variation coming in from the machine itself. Same thing with the supplier qualification process or advanced testing on inbound inspection, or from an environment and prescriptive analytics where I can close the loop and say that if my humidity is going up, I automatically make these changes in the controller and so forth. So those are things that have a systemic change to long-term impact, but they're not going to help at the individual millisecond level. And so you can see that range of different initiatives that you can put in place, which, going back to what you said in the last slide, Sree, the reason that you want to say go down through that root cause analysis is to understand what is it that's driving that variation in the process so that you can pick the right things from this list. If we just say, hey, I've got a first pass yield problem, so that means that I'm going to put in a quality management system, or I'm going to implement SBC, that may not be the right thing depending on what is the source of my variation.
Also, Tim, how we manage first pass yield is also going to be, specific to an industry, and it'll
Yes,
also depend on the plant environment. Are we dealing with an older plant with more manual processes, or is this a, greenfield site with advanced automation? That'll also impact at what level of that control loop you're able to manage that, right?
exactly. If I've got modern equipment that has advanced controllers in place, I can start to think about, can I do actual closed loop process control? If I've got 1940s hydraulic press and so forth, that's not really an opportunity. So we have to take in consideration the environment as we're going through doing that analysis and tying that into what are the possible enablers that we could look at.
Yep. So now we can overlay the process, people, and policy aspects, starting with process.
Yeah, so if we look at the process, one of the core things here is obviously the standard operating procedures, making sure that we have those in place and that they're visible as possible for the people that are doing the work. Where we can, we want to actually get into the process control itself and automate those operating procedures directly into the controller so that we don't have to worry about people setting it up correctly and so forth. And then at the very high level there, we want to have good coordination between manufacturing and design so that the information from manufacturing is going back into the design process so that the next iteration of the process is continually easier to manufacture if possible. From a people perspective, having the visible SOPs is critical. Being able to do education and upskilling, retention programs at the higher level are things that are going to make that longer term impact. And then again, down at that lower level, how can we help the people in real time by putting a video monitoring system in there and giving them that real time feedback of when they deviate from the standards, letting them know that so that the next iteration of the next part that comes through, they'll actually do the standard work correctly. And then at the management level, this is all obviously more longer term in terms of hours and days that we're looking at things, but putting in place Kaizen projects and improving those other aspects of how we're doing the work instructions and all these other things that we've been discussing is important. Putting in a Lean Six Sigma program if you don't have one, or making it more endemic throughout the organization is something that's going to be very valuable in the long term. And then just creating a collaboration within the organization and building that sense of community so that people really do work together hand in hand between engineering and maintenance and production to really drive that improved quality.
So taking a step back here, it is a complex diagram. Hopefully you were able to follow us through the thought process and the logic. But one of the reasons for taking this approach is, could something like this be used to help think through and brainstorm the work process / use case?
Yep.
Because as you can see, once you've designed this, going back to the point we've made a couple of times, is that instead of having an RFP for an MES or a specific system, you actually look at how you're going to redesign the work and then map to what are the enablers and, which may be one or more systems, and how you do that. Again, this is meant to be we've shared enough to get you jump started on the brainstorming process, right?
Yeah, and a lot of times you're going to do more than one thing here. So for instance, if the machines are an issue, maybe you put the condition monitoring system in place, but you also look at how you do the maintenance programs overall, utilizing that information from that real-time monitoring. And so there's things that you can kind of naturally pair up between different suggestions on the chart.
All right, then finally, in terms of closing thoughts, since we're talking about metrics, we should say a few words on the topic of leading versus lagging indicators as you think about your use case and how you intend to deploy it.
And a given metric can be both a leading and a lagging indicator. As we're showing here for first pass yield, first pass yield is itself a leading indicator for something like warranty issues or perfect order, because if you have high variability in the process that's generating rework, some of that will get through and end up in those warranty and perfect order calculations. And then if we look at something at the lower level, like control parameters and those real-time monitoring that we discussed in the last slide, those are going to be leading indicators for the first pass yield itself, as well as supplier quality. If I am having all kinds of issues with my incoming material, that's going to be a leading indicator for my first pass yield. And so depending on the time frame that you're looking at, most metrics can either be a leading or a lagging indicator for a different metric.
Great. So that's the first episode. We've covered a lot in a little time, but we hope that you can see the value of the use case template and how we are connecting the dots and how we plan to follow this structure for the rest of the series. So we'd love to get your feedback on what we presented. Tell us what you liked and where we could improve. Maybe there's some parts that could be made clearer. And feel free to reach out to us if you have a discussion on a specific topic or something specific to your own digital manufacturing journey.